Good afternoon, everyone. Let's move on to paper presentation. We now request Dr. Anthony Linolin, Assistant Professor, PG, and
Good
Research
afternoon,
Department.
ma'am. Welcome, ma'am. Good afternoon, ma'am. Anisha, ma'am. Welcome, ma'am.
Good afternoon, Rita.
Okay. MC girls, start now.
Yes, ma'am. Good afternoon, everyone. Let's move on to paper presentation. We now request Dr. Anthony Linolin, Assistant Professor, PG, and Research Department of Mathematics, Polytechnic College, to take charge for paper presentation.
Good afternoon, everyone. I'm happy to welcome you all for the second day paper presentation session. It's a great pleasure for me to introduce the chairperson of today's session, Dr. B. Anushya, Associate Professor, Sita Lakshmi Ramaswamy College Autonomous, Trichy. Ma'am has 30 years of experience in the field of teaching parlance. Her area of specialization is fuzzy optimization. She has authored or co-authored more than 70 papers in both national and international journals. She has been a member of various committees, which has been a credit to the college and department. A hearty welcome to you, ma'am.
Thank you, Dhanalakshmi. Thank you, ma.
Ma'am, kindly take off the session, ma'am. Yes, ma'am. Thank you, ma'am.
You can start. You can start.
Miss Dhanalakshmi.
Vinolin,
Yes, ma'am.
Hello.
before that, I want to speak something. Vinolin,
Yes, ma'am.
I want to speak something.
Yeah, ma'am. Go ahead, ma'am.
I welcome all the paper presenters to this section. I thank the organizers of this international seminar on present trends in applications of mathematics. Especially, I thank Dr. W. Rita, Head PG and Research Department of Mathematics, Polycross College, for the opportunity given to me to act as a chairperson for this paper presentation section. The allotted time for each participant is 5 minutes. Kindly stick on with the time. I welcome all the paper presenters once again.
Hello.
Yes, Miss Dhanalakshmi can start now.
Yes, ma'am. Shall I present my slides?
Yes, ma'am. Yes.
Hello. Yes. Okay.
Dhanalakshmi, you proceed.
Yes, ma'am. Ma'am, can you all seeing my slide?
It's not visible. It's okay now.
Is it visible now, ma'am? Yes, ma'am.
Okay.
Ma'am, shall I present now?
You can present.
Good afternoon to all. I'm Dr. A. Dhanalakshmi, Assistant Professor of Mathematics, Sri Chandrasekharendra Saraswati Vishwa Mahavidyalaya, Kanchipuram. So today I'm going to paper on the topic spectral properties of King's graph. My abstract is spectra of the graph is referred as the eigenvalue of the matrix related to it. Graph energy of the graph is sum of the absolute value of the eigenvalues of adjacency matrix. In this paper, I obtained the spectra of adjacency matrix and its properties. Graph energy for King graph with one row with n column, two rows with n column, like that way m rows with n column. Not only that, it has been extended to till a square King's graph. Introduction. There are numerous applications of graph theory. We have, especially spectral graph theory has many applications in biology, geography, economics, social science, computer science, and etc. A central goal of graph theory is to deduce the main properties and the structure of a graph from its invariants. Spectral graph theory is a study of relationship between the topological properties of a graph with spectral properties of the matrix associated with the graph. The most common matrix we are using here is adjacency matrix, Laplacian matrix, like that. So the generally eigenvalues are strongly connected with all key invariants of a graph. They hold health information about that. Generally, when we see the eigenvalues, it will tell about the graph. So these are my literature review. SLE, Zagreb, George, Mohammed Khurram. They have found so many things about this spectral properties. The eigenvalues of G are denoted by lambda 1 of G, lambda 2 G, and so on up to lambda n of G when the graph contains n vertices. Among these eigenvalues, lambda 1 of G is called the spectral radius of G, lambda n of G is the least eigenvalue of G, and the spread of G is defined to be the difference between lambda 1 of G and lambda n of G. King's graph. Now, it is a legal move of a chessboard, simply a chessboard. It has especially M cross N King's graph. It is a map formed from the squares of a chessboard by making a vertex for each square and an edge of each two squares that share an edge or a corner. It has total nm vertices and 4mn minus 3 into m plus n plus 2 edges. If it is a square king graphs, it has n square vertices and 2 into n minus 1 into 2n minus 1 edges. Now, whatever the things I found is the graph energy of the King's graph with one row and n columns. It is E equal to summation of I equal to 1 to n plus 1, absolute value of 1 plus 4 cos pi by n plus 2 into I plus n plus 1. This kind of matrix, actually what is here it is in the figure 1. The adjacency matrix of this one is AP plus 1, mn plus 1, mn plus 1 and AP plus 1. Actually, what is P plus P of n plus 1? It is a path graph when it contains n vertices. N vertices, we have n plus 1 path graph. So this is the decomposition of the matrix of the adjacency matrix. It should be splitted like this way: A into 1001 identity matrix plus M into 0110. This can be written as AI2 plus MAP2. For identity matrix with 2 rows and 2 columns, the eigenvalues are 1, 1 and eigenvalues of AP2, that is path matrix, is 1 and minus 1. Now, we have to find the eigenvalues of A plus M and A minus M. That is the eigenvalues of this AP of n plus 1, Mn plus 1, Mn plus 1 and AP plus 1 matrix. And here, the eigenvalues of A plus M are In plus 1 plus 2 into A of P of n plus 1. This one is 1 plus 2 into 2 cos pi n plus 2 into I. Generally, eigenvalues of the path matrix, path graph is 2 into cos of pi by n plus 1 into I. Here we have path p n plus 1, so it should be like this. So when we simplify, we are getting like this. So eigenvalues of A, M, I are, it should come minus 1 into I n plus 1. So we have n plus eigenvalues all minus 1 only. So graph energy equal to summation of absolute values of all those eigenvalues. So when I multiply, it will come from I equal to 1 to n plus 1, whatever the values we have given here. So this is the graph energy for a King's graph with 1 row and n columns. Like that way, in this I have find one more thing is spectral radius and the least eigenvalue and the greatest eigenvalue. So here the spectral radius, that is the greatest eigenvalue, lambda 1 equal to 1 plus 4 cos pi by n plus 2, and the least eigenvalues lambda n equal to 1 plus 4 cos of n plus 1 into pi into n plus 2. The spread is nothing but the difference between the least and the largest one. So we have here 4 cos pi by n plus 2 minus cos of n plus 1 pi by n plus 2. Similarly, this is the graph energy for a King's graph with 2 rows and n columns. We have here like this way. In this, the adjacency matrix, it comes the same format I used, same decomposition I used, with same P of n plus 1. So that time it should come a square matrix of order 3. That should be splitted as again ai plus m into path graph. P of n plus 1. Again, have find the eigenvalues of those things, and I add it. I'm getting this. This is the graph energy for a King's graph with 2 rows and n columns. So similarly, the spread and the least largest eigenvalues of a King's graph with 2 rows and n columns has been given here. So next, 3 rows and n columns, similar way. Hello.
Dhanlakshmi,
Yes, ma'am. Hello.
to the conclusion.
Hello. I'm not hearing you clearly, ma'am. Hello.
5 minutes over. The allotted time is over. Please go to
Okay,
the
ma'am.
conclusion.
So shall I conclude it?
Okay.
Yes, ma'am. Yes, ma'am. So, this is the eigenvalue, that is a graph energy of a King's graph, that is square's King's graph. So these are all my reference. Thank you, ma'am.
Dhanalakshmi,
Yes, ma'am.
why you have chosen King's graph particularly?
Ma'am, this graph, there are so many topological indices already they have find it, but the spectral properties not yet find, I think so. That's why only, and it is one of the challenging issue. So I started this work 1 year before, but it takes so much time to continue it. So that's why only I chosen this one.
Okay. Especially, what is your contribution in this paper?
Ma'am, full of spectral properties, ma'am. So for spectral properties, no one has touched in this King's graph. Maybe topological indices, some other thing, dominations, those things they have find it. But the spectral properties, I think I only have started.
Okay. Thank you for your presentation.
Thank you, ma'am. Shall I stop my sharing?
Okay.
Yes. Yes. Yes,
Before I
Dhanlakshmi.
you call the next person.
Next person is Mrs. Yes, Arogyamedi.
Yes, ma'am.
Start your presentation now.
Yes, yes, ma'am. Good afternoon, everyone. I am Arukya Mary, currently doing my PhD and guidance of Dr. M. Mary Majorolo Merlin. I am here to present my work, which is Impact of Beliefs on Self-Love using Super Fuzzy Relational Maps. My objective is to study the construct of human belief system, to recognize the components of self-love, and to find the causal relationship between belief system and self-love. The main aim of this research is to model the complex system or the complex relationship between human belief system and self-love. Here I make use of the fuzzy tool called Super Fuzzy Relational Maps. What is fuzzy relational map? It is a directed graph with no interrelationship among the nodes in the domain space or range space. Fuzzy relational maps are used to find out the relationship between two disjoint sets. This is actually analogous to fuzzy cognitive maps. The only difference is in fuzzy cognitive maps, the nodes are concurrently active, whereas in fuzzy relational maps, the nodes are divided into two disjoint sets. It can be picturized this way. This D1, D2, D3s are attributes in the domain space, and R1, R2, R3, R4 are attributes in the range space. So this matrix can, sorry, this map can be represented this way, where 0.3 is the relationship between D1 and R1, the first attribute in the domain space and the first attribute in the range space. So wherever there is no relationship, you represent it with zeros. If there is any negative influence, we represent it with negative numbers. So if there are few numbers in the domain space or the range space, we can make use of fuzzy relational maps. What if the number of attributes in the domain space or range space is in hundreds or thousands? Or if there are some sub-attributes in every attribute? In that case, we need a little sophisticated relational maps. So therefore, I make use of super fuzzy relational maps to study this complex causal relationship. So super fuzzy relational maps are similar to fuzzy relational maps. The only thing is there is increased number of attributes in the relational in the domain space and range space. So this can be represented this way. This is actually, this kind of super matrix was introduced by Paul Haas in 1980s, where each component is itself is a matrix. Each component itself is a submatrix. So the operations also explained in his book Matrix Algebra for Social Scientists. I make use of this tool, this idea to study this psychological problem. So this is the super relational maps, where this is my domain space. Number of attributes are there, where each attribute will have some special attributes. Similarly, this is the range space of beliefs, where each attribute speaks of each attribute has some sub attributes also. So here my B1 stands for survival, B2 security, and so on. And my S1, S2 stand for self-love components, which are self-awareness, self-acceptance, self-compassion, and so on. So why did I choose this tool? Because here in this case, a great deal of unsupervised data is involved, and is a relationship between beliefs and self-love. And these beliefs are specific internal states, and self-love is expression of beliefs. So these are two disjoint sets. So this tool would help a lot. This is this is a part of the super matrix. This is the method of finding the hidden pattern in this matrix. So every submatrix, the initial vector is passed through every submatrix. The limit point is obtained. Using this limit point, a new fuzzy relational matrix is formed. Sometimes it may not be fuzzy matrix. When we augment the matrix, I fuzzify it by using sigmoidal functions. Then the resultant matrix, through the resultant matrix, again an input test, and final output is obtained. So from this writing, I have not represented the fixed points here, but only the conclusion. So the influence of self-love is the self-awareness and self-compassion behave the same way. That means self-awareness is the ultimate component of self-love, which will result in, which will influence life very much positively. These are my references.
Okay,
Yes,
go to conclusion. Okay, ma'am.
yes, ma'am.
The time is over.
Yes, ma'am. Hello.
Arogya, what is your conclusion? Arogya Mary, what is your
Yes, ma'am.
conclusion? Give me your conclusion.
Ma'am, actually, we get fixed points from this dynamical structure. I have interpreted the fixed points here, ma'am. How self-love
Actually, what
influences.
your contribution of work?
Ma'am, not able to.
What is your contribution of work in this paper?
I have applied this super fuzzy matrix, ma'am. I have made use of this super fuzzy matrix. Super matrix, actually, it was introduced by Frost. I have made use of it to study this complex system.
Okay, thank you for your nice presentation. Vinolin, call the next
Yes,
candidate.
ma'am. Yes, ma'am. Yes, ma'am. Mr. A. Tausif Ahmad.
உழப்பு வேறடா இதுக்கு என்னடா கேட்குறது?
Ma'am, is it visible? Hello?
Yes, sir. Yes.
Yes, visible, sir.
Okay. I am A. Tausif Ahmad. I am leading to PhD degree course under the guidance of Dr. U. Rizwan, Associate Professor and Head, PG and Research Department of Mathematics, Islamia College, Autonomous Vanambadi. My paper title is Testing Bivariate Exponentiality Against Bivariate Increasing Failure Rate Average Aging Class. In this, a new test statistic for testing whether a lifetime distribution belongs to a class of bivariate exponential distribution with exponential minimum against the very strong version of bivariate increasing failure rate average is proposed. We established the asymptotic normality of the test statistic and its consistency. Numerical studies carried out to check the validity of the proposed test. Finally, application to real life data is carried out. Introduction. In reliability theory, the univariate aging class of lifetime distributions are defined to categorize the lifetime distribution according to their aging properties. The class of increasing failure rate average distribution plays an important role in medical diagnostic. It is the smallest class of lifetime distribution containing the exponential distribution which is closed under the formation of coherent system. Multivariate version of increasing failure rate average class of lifetime distribution was developed by Marshall in 1979. A study on univariate aging class of lifetime distribution for increasing failure rate average was proposed by Rajeshwari in 1983. Now we propose a test statistic for testing bivariate exponentiality against the very strong version of bivariate increasing failure rate average aging class of lifetime distribution based on U statistic. Bivariate aging class of lifetime distribution have been found to be useful in reliability analysis, application in engineering, queuing theory, medical diagnostic, and many other fields. Bivariate distribution are observed in different practical situations. For example, in the survival of the paired organs such as a person, eye, hair, kidney, and lungs, or in the survival of the two-engine aeroplane. Definition. Let x comma y denotes the Let x comma y denotes the survival time of a device having a joint distribution function f of x comma y. The bivariate joint survival function is given by f bar of x comma y is equal to probability of x greater than x, y greater than y. X comma y is greater than or equal to 0, where it is assumed that f bar of 0 comma 0 is equal to 1. Then we define the definition of a star-shaped function. A function g of x is defined on 0 comma infinity is the star-shaped if g of alpha x comma beta y is less than or equal to root of alpha square plus beta square of g of x comma y. Test for bivariate increasing failure rate average aging class. We test in null hypothesis H0 against the alternative hypothesis H1 that F1 belongs to bivariate increasing failure rate average, but it is not bivariate exponential. let h not equal to f bar of x comma y equal to exponential minus lambda minus lambda 2 y minus lambda to maximum of x comma y for all x comma y lambda 1 lambda 2 is greater than 0 and lambda 1 comma 2 is greater than or equal to 0. Alternative hypothesis is f bar to the power of root of alpha square plus beta square into x comma y less than or equal to f bar of alpha x comma beta y for all alpha comma beta belongs to 0 comma 1 x comma y is greater than 0. Then we prove the lemma to show that if f bar to the power root of alpha square plus beta square of x comma y is f bar of alpha x comma beta whole static alpha naught comma beta naught belongs to 0 comma 1, then it will distribution with exponential minimum. It is sufficient to prove that the distribution z at k is equal to minimum of x at k comma y at k. Then we prove this lemma. A statistical test for testing H0 against the alternative hypothesis H1 on the basis of a bivariate random sample x1, y1, etc., xn, yn of the size n from the distribution f is proposed in this section. We define delta of f is equal to integral 0 to infinity f bar to the power 1 over root of alpha square plus beta square of alpha x comma beta y minus f bar of x comma y into df of x comma y. Under H0 delta f is equal to 0 and under H1 delta f is greater than 0, then delta f is a measure of deviation from H0. Applying the classical non-parametric approach of replacing f bar of x comma y by f at n bar of x comma y, where f at n bar of x comma y is equal to n of x comma y over n, where n of x comma y is the number of xi comma yi such that xi greater than x, yi is greater than y, suggesting that rejecting h0 in the favor of h1 if j at n is equal to u at 1 minus u at 2 is large, where u1 is equal to this, u2 is equal to, then we prove this theorem. The limiting distribution root n into j at n minus delta of f is normal with mean 0 and variance sigma square, where sigma square is equal to 9 sigma 1 square plus 4 sigma 2 square minus 12 sigma 1 2. Proof. Since the expansion for the variance of root n under H0 is very complicated, we use jackinifying to estimate the variance of root n jn. The estimate of variance of root n jn is n over n minus 1 into summation I is equal to 1 to n j at n comma I minus j at n star whole square. Used from SEN 1977, it follows that the asymptotic normality of the test statistic j root n into jn over variance of root n jn whole to the power half is asymptotically
Ma'am, 5 minutes.
ma'am. Just I will complete 1 minute, ma'am. The data are given in table 1 which denotes the length. Hello, sir, madam, I will finish in the second.
Okay, sir. Okay. Right.
Using the data in table 1, we obtain the value of the test statistic Jn, that is delta of f is equal to 0.1. Thus, root n jn over variance of root n jn whole to the power half is equal to 4.6051. Hence, we reject H0 and conclude in the favor of bivariate decreasing failure rate. Very strong question. We accept the H1. It shows that failure rate of this property, favorite exponential. Conclusion. Statistical test for testing bivariate increasing failure rate average aging class of lifetime distribution has been developed. Also, the asymptotic normality of the statistic and its consistency are discussed. Numerical studies carried out to check the validity of the proposed test. Finally, application to real life data is carried out. These are the references I have referred to prepare this paper.
Thank you for your presentation, Ahmed. Why have you used the exponential distribution particularly?
What, ma'am?
Why have you used the exponential distribution for your discussion?
Madam, we have used already. The authors have used by univariate exponential distribution for testing the univariate aging class. I have used bivariate exponential distribution to I have used bivariate exponential distribution to use for bivariate aging classes, ma'am.
Okay. Then have you used any statistical packages for getting the results?
Yes, ma'am. I have used R code
Which one?
to come R programming.
R programming. Okay, fine.
Okay,
Thank you.
okay, thank you.
Vinolin?
Ma'am, yes, ma'am.
Next
Ma'am,
Captain.
the next paper presenter is Dr. Bhavadosh, ma'am.
Okay.
Present here.
Yes, sir, you can present now.
Good afternoon, all of you. I am sharing my presentation. Hello, madam. There is some problem in uploading my presentation. Can I give my presentation without uploading? Hello. Hello.
Sir, you can't able to present, sir.
I am trying to share my PPT, but it is not sharing. There is some problem.
Okay, wait for some time. Lastly, you join, sir.
So I can present without sharing my PPT.
Vinolin, what
Ma'am.
he is telling?
Ma'am, he is having some problem in presenting the screen, ma'am. So without presenting,
Without sharing the,
yes, ma'am, yes, ma'am. He is having some problem in the system.
we will do now.
Hello. PPT is not uploading, madam.
Shall we call the presenter?
So I can present without uploading. Hello. Can allow me without uploading my PPT?
Ma'am,
What we will do, ma?
sir, able to present, sir?
Ma'am?
Able to.
Sir, able to present.
Sir, present your screen, sir.
Sir, present your screen, sir.
I am trying my uploading my PPT, but there is some problem not uploading my PPT.
Are you doing the presentation in the
Can I present without uploading my PPT?
laptop, sir?
Hello.
Sir, are you doing the presentation?
Okay.
Yes, sir. Are you presenting in the mobile or laptop, sir?
Okay. I have laptop.
I will call you back, sir. Shall I call the next
Okay.
participant? Sir? Shall I call
Okay.
next participants?
Sabina Begum.
Ms. Sabina Begum, next
Yes, ma'am.
participants.
Good afternoon to everyone, ma'am. Shall I share my PPT, ma'am?
Present. Yes, yes.
Good afternoon to everyone. I'm Sabina Begum. This is scholar of Khalid Mohideen College under the guidance of Dr. M. Sumati ma'am. My topic is optimization of a multi-item EVOK model for a single buyer using fuzzy geometric programming. What I like to discuss with you all today, and this is my overview. In this paper, I have to determine maximize the optimum order time interval and minimize the total cost using nonlinear programming technique, a geometric programming method. I have used heptagonal fuzzy number for specification and a Pascal triangle graded mean for despecification. Now, let us move on the mathematical model. Here, I have taken this integrated inventory model is developed by Yang here. For minimizing the total cost, first we partially differentiate TC with respect to T and put it equal to 0. We obtain T and TC value. We will see what is meant by fuzzification. Fuzzification means the process of converting crisp value into fuzzy value. The conversion of fuzzy value is represented by membership function. This is a graphical representation of heptagonal fuzzy number. Next, so despecification is when we convert a fuzzy value back to the crisp value. In that, I have utilized Pascal triangle graded mean method. This is the formula for Pascal triangle graded mean method. Next, move on to the optimization technique. We will consider the geometric programming problem. This is the special kind of nonlinear programming technique. The nonlinear programming technique, that the objective function of the programming problem and the constraints of the programming problem are all in the nature of the polynomial. We solve this problem with the method of primal dual relation using AMGM inequality. Here the primal problem is converted to dual problem. That is, the minimum TC value is converted to maximum dual function. Here the degree of difficulty is 0. So we get the unique solution. Here T1i and T2i get a value of 1/2. We substitute these value into the dual function and we simplify this dual function. We get optimum time interval and the minimum TC value. Next, we see the fuzzy sense of geometric programming solution. Here, the parametric value, ordering cost and demand are taken as a for the heptagon minimum TC, minimum T and TC value. Here, this is a numerical example for the crisp model and the fuzzy model. Next, this table, we observe that the optimum order time interval and the total cost value are obtained by Pascal graded mean is equal to the crisp value. And this is the graphical representation of TC and T value for various such values. Next, we conclude that the geometric programming method have the same result. We see the crisp and fuzzy values are equal. Thank you, ma'am.
Thank you, Sabina, for your presentation.
Thank you, ma'am.
Why you have chosen non-linear programming for your discussion?
Ma'am, I worked with the non-linear programming method such as Lagrange method and Kunteker. In this paper, I used the geometric programming method, ma'am.
Okay.
For minimizing the total cost and maximize the optimum order quantity value, ma'am. For this purpose, I have used the geometric programming method, ma'am.
So for despecification, what is the method you have used?
Pascal triangle graded mean, ma'am. For heptagonal fuzzy number is a specification, ma'am. I used the despecification method is Pascal triangular graded mean method, ma'am.
Do you have any other method than?
Yes, ma'am. I worked a lot of declassification method, ma'am. Graded mean, sign distance method, robust ranking, Jaggers ranking method, ma'am. In this paper, I have used a partial triangle graded mean method, ma'am.
So what is the advantage of it?
This is I think.
Okay, this is one of the method.
Yes, ma'am. Yes, ma'am. Yes, ma'am. This is the one of the method, ma'am.
Okay.
Ma'am. Thank you, ma'am.
Yeah.
Thank you, ma'am.
Call
Yes,
the
ma'am.
next person, ma'am.
Miss Daisy, ma'am.
Yes, ma'am. Shall I
Okay.
share my PPT, ma'am?
Yes, yes.
Yes, you can share.
Okay, ma'am. Okay, ma'am. Thank you. Welcome to all and good afternoon to everyone. I am Daisy. My topic is on single item with fuzzy inventory model using geometric programming approach under the guidance Dr. K. Kayarasi Madam and Dr. M. Sumadi Madam. Content, first one abstract, second one defuzzification method, third one geometric programming mode under Cripps model, fourth one geometric programming mode under fuzzy model, last one numerical example. Abstract. In this paper, single item inventory model with fuzzy parameters is worked out and explained in both fuzzy and Cripps sense. Some of the fuzzy parameters are taken as heptagon fuzzy number. Many kinds of fuzzy number are there. Some of these triangular, trapezoidal, pentagon, hexagon, and so on. In my paper, I used heptagon fuzzy number only. The main object is data and precise data. Then by geometric programming mode, we solve the problem. Geometric programming is introduced by Joner in 1971 and it further developed by Dufin. Geometric programming method is an effective method used to solve a nonlinear programming problem like structural problems. It has certain advantage over the other optimization methods. Here, the advantage is that it is usually much simpler to work with the dual than the primal one. Solving a nonlinear programming problem by geometric programming method with a degree of difficulty plays essential role. Degree of difficulty is nothing but total number of items in objective function and constraints minus total number of decision variables minus 1. In my paper, degree of difficulty is 1. Next one, an inventory model is developed under the following notations and assumptions, where D is a demand, or O is an ordering cost, H is a holding, C is a purchase cost, S and shortage cost, L is a cycle length, and T is a time between 0 to L. TIC is the total inventory cost. Defuzzification method. Next one, robust ranking defuzzification method is denoted by R of AH bar. AH bar is nothing but a fuzzy number, is defined by integral 0 to 1, 0.5, lower bound of AH alpha, comma, upper bound of AH alpha into D alpha. This is the formula for the heptagon fuzzy, robust ranking for the heptagon fuzzy numbers. Next one, geometric programming mode under Cripps model. We consider the total cost, total inventory cost is the equation 1. Here, C minus theta S into D is a constant term. Hence, the total cost becomes the total cost becomes and by using the geometric programming mode and these subjective conditions and solving, we get L1 and L2 equal to L1 equal to L2 equal to 1. Putting these values in the above dual form, we get the following results.
Next one, from the these are the primal dual relations, and solving we get the Cripps cycle length L and Cripps total inventory cost TIC of L. Next one, geometric programming mode under fuzzy model. Here, ordering cost O and demand D are taken as a capital fuzzy numbers, and using robust ranking defuzzification for capital fuzzy numbers, and corresponding to the dual form of the equations and the subjective conditions, and solving, we get the following, we get the answers L1 equal to L2 equal to 1 by 2. Putting these values in the above dual form of the dual form, then we get the optimal solutions. That means fuzzy cycle length L and fuzzy total inventory cost DIC of L are obtained from geometric programming mode. And next one, numerical example. Let us take ordering cost 300 per cycle, H equal to 1.5, C is 25 per unit, S is S equal to 5 per unit, D 500 units, and theta equal to 5.46. Putting these values in the Cripps cycle length and Cripps total inventory cost, we get the answer L equal to 6.24 and TIC of L equal to 14,461.51. Fuzzy model, here ordering cost and demand is taken as a capital fuzzy numbers. We get the answer is same as the Cripps answers. Next one, this figure indicates the graphical representation of the above results, above Cripps and fuzzy models. Next one, when D increases the value, then its optimal solution DIC of L are also increases. Whatever the value are given the following table. This figure indicates the graphical representation of the above table. Conclusion, in this paper, geometric programming mode for finding the optimal solutions to minimize the total cost and maximize the total profit of fuzzy inventory model, in which ordering cost and demand taken as a capital fuzzy number and solved by using robust ranking defuzzification method. The conclusion is, the conclusion of this proposed model, Cripps sense is very close to fuzzy sense. Thank you, ma'am. Hello, ma'am.
Daisy, thank you for your presentation.
Yes, ma'am. Thank you, ma'am.
Why have considered heptagonal fuzzy number?
Already I used a triangular, trapezoidal, pentagonal fuzzy numbers, ma'am. So this paper I used a capital fuzzy number.
So, have you got any advantage in using this heptagonal fuzzy number? Already you have used two type of numbers, no?
Yes, ma'am. Yes, ma'am. But this method, geometric program is not not used, ma'am.
Have you found
I work. Yes, ma'am.
Have you found any advantage in using this kind of fuzzy number? No.
No, ma'am. It's one of the method, ma'am.
What number?
It's one of the numbers, ma'am. One of the numbers.
Any numbers, fuzzy numbers?
Fuzzy numbers, yes, ma'am.
So that you have used heptagonal. That's all.
Oh, yes, ma'am. Yes.
Actually, what is your contribution in this paper?
Yes, ma'am. Minimize the total cost, ma'am, but maximize the total profit, ma'am.
Okay. Okay, Daisy. Thank you.
Thank you, ma'am. Thank you so much, ma'am.
Binolin, you call the next person, ma'am.
Ma'am, Dr. Yokesh Sharma, ma'am.
Oh, he's all right now.
Good afternoon.
Good afternoon, sir.
Now I will present my paper first.
Binolin,
Ma'am, sir has left the meeting, ma'am. Shall I call the next presenter, ma'am?
you call the next one.
Yes, ma'am. Mr. K. Keshav Kumar.
Keshav Kumar. Mr. Keshav Kumar, You come and present the paper. You present your paper.
Sir, Mr. K. Keshav Kumar.
Keshav Kumar, are you here?
Mr. Yogesh Sharma, are you here? Mr. Yogesh Sharma, are you here? Ma'am, shall I call the next presenter, ma'am?
Yeah.
Ma'am, shall I call the next presenter, ma'am?
Yeah. You call Vinolin.
Mrs. Annie Lydia, ma'am.
Okay.
Annie Lydia. She is also not here, ma'am. Shall I call the next one, ma'am?
You call the next.
Dr. R. Vijay Kumar.
Yes, ma'am. Good afternoon to one and all.
Good afternoon, sir.
So now I'm going to share my PPT, ma'am.
Okay, you share.
Yes. So good afternoon to one and all. So this is Dr. R. Vijay Kumar, Assistant Professor, Department of Mathematics, Periyar Government Arts College, Cuddalore. So presently I'm working in this institute in this Government Arts College. So basically I'm from Annamalai University. So my title of the paper is the effect of partial strips and magnetic field on coupled stress fluid. There is an exact solutions. So introduction is after many studies, technology flow of non-Newtonian fluid is very important because of its applications. It plays many important roles in the biological problem, industrial and engineering process. So here I consider the non-Newtonian fluid as a coupled stress fluid. So it was first introduced by the Stokes 1966. It is also very helpful to understand the different physical models because of its process mechanics to describe the realizable complex fluids such as those are given here. So next, so basic paper of to motivate this paper. So there is a so Ilahi and the Divagar is inverted the previous answers for the three fundamental flows, namely cordial and the Poisson flow and the generalized cordial flow with the slip conditions. So here I aforementioned the investigation is study the effect of there is a in a body force. I introduce the body force and the partial slip conditions in this model. So I taken here three fundamental flows, namely the plane cordial flow and the plane Poisson flow. Next one is a plane generalized flow between the parallel plates under the conditions. So this is the model I developed there. So this is the formulations of the solutions of the problem that the governing equation for motions for a non-Newtonian coupled stress fluid. So it is also by Stokes and Divakar for an incompressible fluid. There is for incompressible fluid means so here I consider the fluid as the density is a constant. That is in the presence of external force. There is a magnetic field. So the flow is along x directions. So that is so here I consider the steady laminar flow. So there is a steady means it is independent of time. So there is a laminar means the flow is in the well-defined path. Then the fully developed flow means it is a unidirectional. So unidirectional means so here I consider the flow is along x directions. So the magnetic field apply the vertical of the flow directions. So next one is let here the origin. The origin is taken at the middle of the plates. So now I'm so this is these equations is a governing equations of the flow fluid. That is This one is a continuity equations. So equation 1 represents the continuity equations, and equation 2 is a momentum equations. So momentum equations means that it starts with the Newton's second law of motion. So that is a force. This one is a force. So this one is a force equal to mass into this one is a acceleration. This part. Okay. So force is there is a two categorized one. The one is a body for internal force and external force. So internal force is the pressure, and this one is a stress, and this one couple stress. These are the internal forces. This is the body force. External force means it represents the magnetic field. So with the help of the Maxwell equations, the governing equations, the equation 1 and 2 became the equations. The momentum equations became 3 and 4. Okay. So here there is I consider the 3 cases. One is a plane quantity flow. So what do you mean by the plane quantity flow? Means it is a imperative points of this case. The laminar flow of the steady laminar flow of the incompressible fluid lies between the 2 infinite plates. So here the 3 cases I consider the 2 infinite plates. That is a y is equal to plus or minus such with the effect of the external force. That is a body force. That is a magnetic field. The plane quantity flow of the coupled stress fluids. Here in the plane quantity flow, the pressure is a constant, means the pressure gradient is a negative. So consequently, the velocity is in the flow field. The boundaries are assumed to move with the constant. So in this case, here the pressure is a constant. So this equation, so the equation 3 becomes now the pressure is constant, means this became 0. The pressure gradient became 0. So it represents in the equation 5. So this is the partial slip condition. So there is we classify into 2 types of boundary condition. One is a slip condition and no slip condition. So the slip condition, so there is some velocity, but then the no slip condition means the velocity at the wall is constant. So this one, the partial slip, means we can introduce this boundary conditions. So y is equal to minus and y is equal to plus. So this is for vanishing the coupled stress fluid. We introduce the equation 8. So I introduce the dimensionless parameter to reduce the variables. So I introduce this dimensionless parameter in equation 5 to this 8 boundary conditions. So this is the dimensions of equation of motion, and the corresponding boundary conditions 9 and 10, 11, 12 is the boundary conditions. By the exact solutions of these boundary value problems, after straightforward calculations, we obtain equation, that is equation 3. So this is for velocity in the plane quantity flow. Okay. So by using the equation 13, we find the volume flow rate. So this is Q equal to integral -1 to +1 u of eta into d eta. Equation 14 represents this volume flow rate. In similar manner, we can the case 2 represent the plane Poisson flow. So what is the Poisson flow? Means the Poisson flow, that both infinite horizontal parallel plates are considered as a rest. That is both these planes are considered as a rest. So it flows is due to the constant pressure gradient. So it is the pressure gradient in the positive x directions. So the governing equations become this one. So here the pressure gradient is considered. So here in the first cases, so here the pressure gradient is not considered, means in the slip. So here the u1 and u2. So this is a constant some velocity. Okay, but this one's constantly taken. So in the second cases, it became 0. So here in the case 16, it became 0. Okay, but due to the positive x directions. So
Please, sir.
So I want to tell the conclusion now.
Yeah, come to the conclusion.
Okay. So in similar manner, we can solve the generalized quantity flow. So these are my graph using that velocity and volume flow rate. So the final conclusion. Okay, some interesting result of the 3 classical flow problem, namely Poisson, Corti, and the generalized quantity flow of the incompressible coupled stress fluid between the 2 parallel plates with the partial slip conditions. So finally, it's shown that the effect of coupled stress predominant only for the small values of A. And if A is a very small value, the flow character tends to the equivalent to the Newtonian fluid, because I consider the coupled stress fluid. The coupled stress fluid is there is some A. So A tends to 0 means the flow became a Newtonian fluid. So the result of Divagar from the particular case of the study, the present study, in the sense that the large value of m, the impact of Hartmann number, that the Hartmann number means here the magnetic field, and the pressure gradient decreases the effect of fluid velocity. So this is my conclusions. So these are my references. Thank you.
Thank you, sir. Thank you for your nice presentation, sir.
Okay, ma'am. Thank you.
Audience, if you want, you can ask some questions. Audience, you can ask some questions. Okay. Thank you.
Okay. Thank you. Thank you.
Thank you, sir.
Thank you. Thank you.
Ma'am, I think no question from the audience, ma'am. The next part.
Questions from the audience.
Mr. Kumar.
Okay. Thank you.
Mr. K. Kumar. Sir, get ready for the presentation, sir. Okay. Sir, K. Kumar, sir. Mr. K. Yes, sir. Present your points, sir. Sir, response.
94, 93.
Sir, your voice is not audible, sir. Sir, we are not able to hear from you, sir. Sir, unmute your audio. Sir, we are able to see your video, but your voice is not audible. Can you unmute and speak? Sir, Mr. Kesav Kumar, sir.
What happened, Rita?
But he is speaking, ma'am, but the voice is not audible.
Okay.
Sir, Mr. Kesav Kumar, sir. We are able to see your video, but your voice is not clear. Not able to hear anything from you, sir. Sir, ma'am, I will call upon the next participant, ma'am.
Yes, Rita, you call up.
Sharma. Dr. Yogesh Sharma.
Good afternoon.
Good afternoon,
Now,
sir.
Yes, sir.
I will present
sir.
my paper.
Yes, sir. Yes, sir. Present now, sir.
Just a minute. I will present my paper. Some application of Nunez operator of certain subclass of univalent function. And in this paper, we prove distortion theorem by using Nunez operator for space S naught alpha beta and C naught alpha beta of analytical and univariate function of unit disk U. And my keywords are fractional calculus, distortion property, and analytical function. In this, we take function fz in a form of z plus k varying summation 2 to infinity ak zk, where value of a1 as well as an are greater than 0, and if fz which belong to class T it is form of S naught alpha beta if it satisfied the following condition 1.2. And obviously, value of alpha and beta both lie between 0 to 1. And we just, for proving our result, we take some suitable lemma for space S naught alpha beta and C naught alpha beta. Let any function fz, which are element of S naught alpha beta, then it can be arranged as n varying 2 to infinity this much. And fz, which belongs to C naught alpha beta, if it will be satisfied the condition summation n varying 2 to infinity n minus 1 plus beta 1 plus alpha n operated with an should less than beta 1 plus alpha of n. Now, fractional integral operator, which are defined by several authors, but we take more suitable definition by Londas. I beta gamma k fz can be defined as twice 2 raised to power beta z raised to power 2 gamma minus 2 beta k raised to power 1 minus beta and integral 0 to z u raised to power 1 plus 2 gamma multiplied with z square minus u square beta minus 1 by 2 and j beta minus 1 k z square minus u square f of u, where j beta minus 1 is Bessel function of order beta minus 1. What is the advantage of this operator? If we have to taken gamma by minus beta, then over operator reduce into dz minus beta fz, where dz minus beta fz is fractional calculus operator of order beta, and I have already proved in my earlier paper. Now, if beta is greater than 0 and P is greater than gamma minus K minus 1, then we prove the result I0 Z beta gamma neta ZP is equivalent to this much. By simply, if we taken in Londas operator Fz by Z of P, we obtained this result by using table of integral transfer. Now, if K approaches to 0, then above operator reduce in terms of Ardley-Kober operator E0Z beta gamma neta should equivalent to this. Now, if the function fz belongs to the class S naught alpha beta, then we taken I0Z beta gamma neta should equivalent to this. And if the function defined in 1.1 belongs to S naught alpha beta, then we prove these two inequalities I0Z beta gamma k should greater than equal to this quantity, that is 2.5 equation, and also less than equal to 1 plus this equation 2.6. And some more application of Londas operator, if we taken Z which are belongs to U naught, where U naught defined as U when gamma is less than equal to 1 and U minus 0 when gamma is greater than 1, Fz defined by this, then we prove the result I naught 0Z beta gamma k should equal to this much. If we taken h of z is equal to this quantity, where small hn should equal to this, which are non-increasing, and 0 is less than hn is less than h2 should equivalent to this, then we taken summation n varying 2 to infinity an should less than this quantity, we obtain the following inequalities. And similarly, fz defined to 1.1 be class of C naught alpha beta. Instead of S naught, we finally obtain these two inequalities, first and second. Again, for this, we taken f of z equivalent to a1z minus beta 1 plus alpha a divided with 2, 1 plus beta upon 1 plus 2 alpha z square. And these are my references. Thank you. Hello. Any questions?
Any questions from the audience? Thank you, sir. Thank you for your nice
Okay, ma'am.
presentation.
Thank you, ma'am. Thank you.
Audience can ask questions. Thank you, sir.
Okay, ma'am. Thank you.
Thank you. Vinolin? Vinolin?
Yes, ma'am. Yes, ma'am. Ma'am, next presenter is Mrs. Annie Lydia, ma'am.
Okay. How many presenters are there remaining?
5 more, ma'am.
5 more. Okay. She's the sixth candidate. Huh?
Yes, ma'am.
Okay.
Ma'am,
Okay.
can you give last?
Ma'am, I am Anne Lydia, ma'am.
Yes, ma'am, you can present.
Okay, ma'am. Okay, ma'am.
Lydia, you present.
Okay, ma'am. Okay, ma'am. மழை வந்துச்சு நான் கொடையை எடுக்காம வீட்டுல இருந்துட்டேன்.
Good afternoon to all. Welcome to my presentation. Ma'am, can you hear me, ma'am?
Yeah, it's okay.
Okay. I am Annie Lydia, research scholar, MS University, Tirunelveli. My topic is snake-related perfect mean cordial graphs. Definition: A mapping FV of G to 0, 1 is called binary vertex labeling of G. Here, in binary vertex labeling, we use the vertex 0 and 1. Also, the condition is mod f of u minus f of v. Here, v f of I is the number of vertices labeled with G, and e f of I number of edges in capital G. A binary vertex is called cordial labeling when it satisfies the condition vf of 0 minus vf of 1 less than or equal to 1 and ef of 0 minus ef of 1 less than or equal to 1. Also, next, the definition of mean cordial labeling. In mean cordial labeling, we use the edges as 0 and 1 and 2. Also, vertices also 0 and 1 and 2. Here, we follow the condition uppercase of f of u plus f of v by 2. Also, mean cordial labeling satisfies the condition vf of I minus vf of j less than or equal to 1 and mod ef of I minus ef of j less than or equal to 1. In 1987, Cauchy introduced the concept of cordial labeling as a weaker vision of graceful and harmonious labeling. Motivated by mean cordial labeling and cordial labeling, we find a new definition. It's called perfect mean cordial labeling. In perfect mean cordial labeling, the vertex set is denoted by 0, 1 and 2. The edge set is denoted by 0 and 1. Also, the conditions are ef of 0 minus ef of 1 less than or equal to 1 and vf of I minus vf of j less than or equal to 1. If a graph satisfies this condition, it's called perfect mean cordial labeling. It's an example of perfect mean cordial labeling. All of you see, here the number of vertices labeled with 0 is 1 and the number of vertices labeled with 1 is 1 and the number of vertices labeled with 2 is 2 and the number of vertices labeled with 3 is 2. So, it satisfies the condition vf of I minus vf of j less than or equal to 1. Also, number of edges labeled with 0 is c and the number of edges labeled with 1 is 2. So it satisfies the condition EF of 0 minus EF of 1 less than or equal to 1. So the graph satisfies all the conditions of perfect mean cordial labeling. So it's called perfect mean cordial graph. A cycle with 6 vertices is not a perfect mean cordial graph. Our definitions are a double triangular snake, a double alternative triangular snake, a double alternative quadrilateral snake. First, we prove double triangular snake is perfect mean cordial labeling. For that, we mark the vertices as first the path as UI, the upper vertices as VI, and the lower vertices as WI. So we mark UI if 0i congruent to 0 mod 4, 1i congruent to 1 mod 4, and 2i congruent to 2 mod 4, and 3i congruent to 3 mod 4. Also, we mark the vertices height of VI 2, 0, 3, 1 and height of WI 1, 2, 3, 0.
Please solution.
All so he the selected graphs of cordial all mean cordial condition. It is.
Thank you, Lydia.
Okay.
You have discussed your findings here, but what will happen to this perfect mean cordial labeling if you consider directed graph?
Not direct. Here the graphs are undirected graphs.
Undirected. Can you think of directed graphs?
No, ma'am. I considered it as my future work, ma'am.
Okay. Okay. What is your contribution in this paper?
It is all my work, ma'am. We and my guide only find perfect mean cordial labeling. It's my new definition in labeling world.
Okay. Are you doing PhD now?
Yes, ma'am. I am in the ending level of PhD, ma'am.
Okay. Okay. All the best for your early submission of the thesis.
Okay, ma'am. Thank you, ma'am.
Okay. Thank you. Univalent.
Ma'am, yes, ma'am. The next presenter is Mr. M. Yanashekhar, ma'am.
Yanashekhar. Okay, ma'am.
Yeah. Thank you, ma'am. Ma'am, is it audible?
Yes. Yes, it is audible, sir.
Just a minute, ma'am. I will share my screen. Ma'am, is the screen is visible?
Yes, sir.
Thank you, ma'am. Good evening to everyone present here. Myself, M. Gnanasekhar, Assistant Professor, Department of Mathematics from Rathinam College of Arts and Science. It is located in Coimbatore. In today's my topic is number in tensor and comp product of graphs. Okay, so these are all the basic definitions. So in this basic definition, I have defined some basic concepts are like a distance, what is a geodesic, then what is a closure. So these are all properties I have discussed here. Okay, so basically the distance is the shortest path between any two vertices is called as a distance. Okay, so here we have we called as a geodesic, that is a shortest UV path. Okay, so then we move on to the interval. So interval is nothing but the shortest path between, or the possible shortest path between versus the interval. Okay, so then we move on to the closure. The closure is the collection of interval. Okay, so already we defined the interval. Okay, here we have collect that is a union of all the intervals, the possible intervals between any two vertices is a geodesic closure. Then we define the geodesic set. Geodesic set is nothing. Here the our closure set should contain all the vertices of that graph. Okay, so that is called as a geodesic set. Okay, so then we move on to the geodesic number. Geodesic number is the minimum cardinality. That is minimum cardinality of the geodesic set is called as a geodetic number. Okay, so some of the concepts here. There is a linear geodesic set. Linear geodetic set is that satisfies the corresponding points. Okay, so that is linear geodesic set. Then we move on to the Cartesian product. Okay, so the one of the main product in mathematics, that is a Cartesian product. Okay, so here we have defined the Cartesian product and tensor product. So these are all the basic concepts in graph theory. So next we will define the comp product. Okay, so these are all the known result from Boson, Bracer, Sandy Cleveler, Alexandra Topowert. Okay, so these are all the basic concepts related to product graphs. Okay, so I have used this concept to deriving my result. Okay, so these are all the basic result. If you get Cartesian product of two graphs, these are all the basic concept for the matrices. Okay, so straight away I move on to the my okay, so here I have defined one of the lemma. So if G is equal to H tensor Kn, so then the intervals of V of G is like union of I is equal to 1 to n, that is L dash of G. Okay, so this, I have defined another one lemma. So this is based on the walk of the graph. So then lemma. So if we have a shortest path between any two tensor product graphs, okay, so if there is a distance between one, okay, so this is possible for if UP and UK belongs to an edge. Okay, so here I is not is equal to G. I and G are distinct. Okay, so then if UP and UQ belongs to K3, if it is a complete graph of K3, then the result is 2. Okay, so then the similar way UP and UK does not belongs to K3, then the result will be a 3. Okay, so then I have introduced another one lemma. So okay, so this is the diagram for graph of G cross Kn. Okay, so in any graph with Cartesian product of Kn, okay, so there is we have only two vertices. We can cover all the vertices in that graph. Okay, so like I have take two distinct points here, like that is mentioned in the block dotted lines. Okay, so in this line in a tensor product graph, here we have all the edges. Okay, so this is a general graph. That's why I didn't put the all the edges here. Okay, so here all the edges are connected to any other edges. Okay, so here in the first layer I have take one vertices, and the last layer I have take one vertices. These two vertices closer all the vertices of this graph. Okay, so this is one of the result. I got it. I get the geodesic number of PM tensor Kn is equal to 4. Okay, so this is satisfies the equality constraint, that is a sharp bound. Okay, so this should be in a m is greater than or equal to 4 and n is greater than or equal to 3. Okay, so here I have used this proof technique. Okay, so in this first two layers I have take two vertices, and last two layers in anywhere I have took two vertices. These four vertices contain all the cover all the vertices of this graph. Okay, so that is nothing but that is a geodesic. Okay, so these are all the proof technique. If it is, I have proved greater than or equal to condition, then I have proved the less than or equal to condition. From the conclusion, I have get the equality. That is a short bound. Okay, so these are all the induction method. I have choose S is equal to 1 and S is equal to 2 and S is equal to 3 and S is equal to 4. Likewise, I have choose this vertices I have proved. Okay, so our next result is if it is a Cartesian product of a cycle with a complete graph. Okay, so in any cycle with complete graph, I have a result. Okay, so if it is an even cycle, then the geodesic number of that graph is a 4. Okay, so if it is an odd cycle, okay, so then the geodetic number of the tensor product is 5. Okay, so here I have used this technique to prove this
Sir,
Yes, ma'am. Yes, ma'am.
please come to the conclusion, sir.
Okay, so thank you, ma'am. I straight away I move on to the conclusion. Okay, so this is my further work. Okay, so this is my conclusion. I have done these works in this lecture. Okay, so first I have result Pm cross Kn, that is that is the Cartesian product is 4. If it is a cycle with any any complete graph, then the geodetic number is 4. If it is an even, then if it is odd, the geodetic number is 5. Okay, so then I have found a Km cross Kn, that is a general graph. Okay, so the result will be a 5. Okay, so then I have found the one of the result Pm tensor Cn. Okay, so which is less than or equal to 4, where m greater than or equal to 4 and n greater than or equal to 4, where n is odd. Okay, so I have found some other result Cm tensor Cn. If it is odd cycles, then 4. If it is an even odd, then the result will be 4. Okay, so then I have found the wheel graph. So if it is any wheel graph Pm tensor Wn, the result will be 4. Then the Cm tensor wheel graph 4,5. Then the wheel graph tensor wheel graph, the result will be 5. Okay, so then I have found the result from comp product. So in this comp product, I have done these result. Okay, so these are all my references. So thank you.
Thank you. Thank you for
any questions? Thank you, ma'am. Any questions?
Sir, why you have particularly chosen comb product graphs?
Nobody work with comp product. Already we have a geodetic number in certain products like lexicographic product, strong product, Cartesian product. Like that we have a result. Tensor product, I have found the result. Then now I working in comp product. So comp product, I have this result. I work further. I will work further.
Okay. Okay, sir. Thank you.
Thank you, ma'am. Thank you, ma'am.
Ma'am, the next one is Dr. J. Sengamala Chelvi, ma'am.
Sengamala Chelvi. Okay. Only 2 remaining. Univalent. 2 members are there.
Ma'am. 4, ma'am.
4. You said 5 candidates are remaining. Univalent, who is presenting now?
Dr. Sengamala Chelvi.
Yeah, ma'am. Good afternoon. Good afternoon, everybody.
Present.
Yeah, I am going to present. Yes, can you see my screen, ma'am?
Yes, ma'am.
Yes, good evening to all. This is Dr. J. Sengamarachelvi, Assistant Professor of SCSVM University, Conjipuram. So my topic is application of fuzzy soft matrix in day-to-day life. Before that, I am going to explain some basic properties of the fuzzy soft matrix. So what is fuzzy soft set is, let U be an initial universe set and E be the set of parameters. Let P of U denotes the set of all fuzzy sets of U. Let A containing or equal to E, a pair FA, E is called a fuzzy soft set over U, where FA is a mapping given by FA, E tends to P of U, such that FA of E equal to null set if E does not belonging to A, where pi is the null fuzzy set. So this is the definition of the fuzzy soft matrices. Let FAE be a fuzzy soft set over U, then a subset of U cross E is uniquely defined by RA U comma E, where E belonging to A and U belonging to FA of E, which is called the relation form of FA comma E. The characteristic function of RA is written by mu RA U cross E is tending to 0 comma 1, where mu R comma A mu comma E U comma E belong to 0 comma 1 is the membership value of U belonging to capital E for each E belonging to U. We know that capital U is the inverse set and E is the set of the parameters. So if mu ij equal to mu Ri of ui comma ej, we can define a matrix in this way. So which is called the M cross N soft matrix of the soft set Fa comma E over U. Therefore, we can say that fuzzy soft set FAE is uniquely characterized by the matrix mu ij, M cross N, and both concepts are interchangeable. So here I gave one example. For example, if you take U equal to U1 up to U5 is the universal set, and E equal to E1 to E4 is the set of parameters, and we can frame and A equal to E1, E2, E3, and we can frame FA comma E equal to in this manner. Then after this we constructed that soft matrix is written as in this way. These are some basic properties of the fuzzy soft matrix. This is the addition properties of the two fuzzy soft matrix. If you define let A equal to Aij M cross N and B equal to Bij M cross N, then its addition of both soft matrix, it can be written as Cij into M cross N, where Cij equal to minimum of 1 comma Aij plus Bij. So this is the definition of the compatible multiplication of the two fuzzy soft matrix. Suppose if the two matrix Aij M cross N cross Bij N cross P, it can be defined as Cij M cross P, where Cik equal to maximum of Aij Bjk for j equal to 1 to n. So these are some proportion of the fuzzy soft matrix. We know fuzzy soft matrix multiplication does not satisfy the commutative law, and it satisfies associative law, and matrix multiplication satisfies law of transposition. Fuzzy soft matrix multiplication does not satisfy the distributive law, and fuzzy soft matrix multiplication satisfies the identity law. Then determinant of the fuzzy soft matrix, let Sn be a symmetric group of 1 to n. Let A equal to mu ij, M cross n be an M cross n fuzzy soft matrix. Then its determinant is denoted by product pi belonging to Sn, A1 pi of 1 to An pi of n, where the product is taken overall of Sn. So here I gave one example how we have to find the determinant of the fuzzy soft square matrix of order 2. So let A equal to A11, A12, A21, A22. No? Its determinant value is minimum of maximum A11, A22, maximum of A21, A12. Here I gave one example of determinant value of fuzzy soft matrix of order 2. If we take maximum of these, both the value 0.7, 0.6 is 0.7, maximum 0.8, 0.3 is that 0. Then we have to take the minimum value. So this is the formula of the determinant of the fuzzy soft square matrix of order 3. Here I gave the one example. This is some properties of the determinant. Then rank of the fuzzy software matrix. It is a fuzzy software matrix is said to be singular if its determinant is equal to 0. It is said to be non-singular if its determinant is not equal to 0. So here I have taken one example. Matrix A. It's singular because its determinant value is a software matrix A. Here I consider one matrix. It is non-singular. Why? Because its determinant value A is equal to 0.2. It is not equal to 0. So yeah, next proportion is a fuzzy soft matrix is singular if all of its main diagonal elements is 0. Then the rank of the fuzzy soft matrix, it is A is defined to be the order of the largest square of some matrix of A whose determinant is not equal to 0. Here I gave one example. Consider this fuzzy soft matrix. Clearly its determinant value is 0. So the rank of the fuzzy soft matrix is not equal to 3. Therefore the rank is 2. Next, eigenvalue of the fuzzy soft matrix. It is definition is let A be a fuzzy soft matrix of order n by n and lambda be a scalar such that lambda belonging to 0, 1. Then lambda is called an eigenvalue of A and a non-zero vector x be called a row or column eigenvector associating with the eigenvalue lambda of A if x equal to lambda x where Ax equal to lambda x. This is a column eigenvector definition.
Ma'am?
Yes, ma'am.
Explanations are not necessary, ma'am. Directly go to your work, ma'am.
Yeah, ma'am.
5 minutes over, ma'am. Allotted time, 5 minutes over, ma'am.
Okay, ma'am. So this is my work. So I have collected some data from government hospital of in Conjipuram. So this is the right time to say my thanks, my heartful thanks to Dr. Greaser. He gave the data to me. So my diagnostic model is formulated by Sanskrit, the physician medical knowledge. Here I have taken B equal to A dot R. Here R is the relation between the symptoms in the set S and disease in the set T. Why I have chosen in the field means the field of the medicine is one of the most fruitful and interesting area of the application of the fuzzy set theory. So I have collected some data and I have applied the basic things and I list out we assume the membership grade is 1, 7.75, 0.5, 0.25 and 0 in fuzzy set R0 and RC for the linguistic terms. Then I apply the basic things. So I gave one example here. I consider that disease S equal to S1, S2, S3 and the set of disease D equal to D1, D2. S1 is high fever, S2 joint pain, D1 arthritis, T2 malaria and S3 is fatigue. So let us assume the medical documentation exists concerning the relation system S1, S2 and S3 to disease D1 and D2 and I got these results. Just kindly go through. So my conclusion is if mu2 I got that p comma d equal to 1. So I conclude that disease D is the confirmed diagnosis for the patient B. In this example from R2 we see this not the case for any of our 3 patients. The disease T1 is strongly confirmed for the patient P3. Second rule is if mu R3 PD equal to 1 I got. So if mu R4 P comma D 1 and the disease D is not the possibility for the patient P. So in our example, the disease D1 may be excluded as a possible diagnosis for patient P1. And the last one is yes, we may include any disease D in the set of the diagnostic hypothesis for patient P if they satisfy the inequality 0.5 less than maximum mu R2 P comma T comma mu of R2 P comma T. So in this example, both disease D1 and D2 are suitable diagnostic hypothesis for patient P2 and P3, whereas D2 is the only acceptable diagnosis for the patient P1. These are the I have found. Thank you, ma'am.
Anisha, ma'am. Ma'am, Anisha ma'am.
Yes, Rita.
Yes, ma'am.
Madam,
Yeah, ma'am.
you have discussed some applications.
Yeah, ma'am.
How you have collected data, real data?
Real data, ma'am. Initially, I found so many struggles and problems when I collected the data. After that, I have to communicate my problem to government GH hospital in Kanjipuram. One sir, Grease sir is there, Dr. Grease sir. So he only gave the data to me, ma'am.
So
And
actually, the data are very real.
yeah, ma'am, of course.
Okay. So what is the advantage of using fuzzy offset in your application?
Ma'am, what I framed the matrix model may not yield a more accurate diagnosis in such cases where a single patient is affected by several diseases. Often single disease manifests quite differently in different patients and at different disease stages, ma'am.
Okay. Okay. Thank you, madam. Thank you for your nice presentation.
Thank you, ma'am. Thank you so much.
Vinolin?
The next presenter is Dr. Samir Kumar, ma'am.
Rita?
Ma'am,
Next presenter
is Dr. Shamir Kumar.
Yes,
Sir?
yes, ma'am.
Dr.
Yes,
Shamir
ma'am.
Kumar, sir.
Yes. Sumit Kumar Bhandari, I am Dr. Sumit Kumar Bhandari, ma'am. Can you hear me, madam? It is audible, ma'am. Hello?
Yes, sir. It is audible.
Audible? Okay. First of all, good afternoon, everybody. First of all, I want to know my heartiest thanks to organizers to give me chance to present my paper. Now I am presenting now skin. Now, okay, just a minute. It is visible now. Is it visible now? Is it visible now, ma'am?
Yes, sir. It is visible.
Okay. I am Dr. Samir Kumar Bhandari from School Vinodi Mahavidyalaya. My title of my paper is Special Type Contraction Result on two major spaces. Here, actual abstract in this base results, I have established a special type contraction result on two major spaces. Two major spaces actually the probabilistic generalization to metric spaces, where a triangular inequality postulated with help of T norm. In 2000, just few months ago, I have just published a paper on calculating Calcutta Mathematical Society, and I have generalized this result. That result I have generalized that result. So here I have used a control function phi, and my research guide, Professor Vinayak Samadda Chaudhary from IIT Shibpur, he and which is another collaborating work with Krishnapada Das, established the control function phi, and I have used this control function in my main result. And here I have given a one corollary, one example to support the result. Yes, ma'am. Any problem? Hello, ma'am. Any problem? Is it audible and visible, ma'am? Yes, ma'am.
Sir, it is
Hello?
audible, sir.
And visible? Visible?
Yes, sir.
Okay.
Yes.
Okay. Can I continue?
Yes, sir. Continue, sir.
Okay. Actually, first of all, here I have used some mathematical tools to establish my result. In 1906, Frechet, mathematician Frechet, first introduced the concept of metric spaces. After that, many researchers, established many results on this paper and many directions. In 1922, S. Banach established Banach contraction principle, and in 1942, K. Menger established first time probabilistic metric space, and it was actual probabilistic generalization of metric spaces. Gaylor established first two metric spaces, and Owen James first established the two probabilistic metrics. It was generalization of two metric spaces, and actually it can be called as a generalization or probabilistic version of two metric spaces. And here also, there are also alternative function, and GVR Babu, Professor G. Babu, a Renard function, he also do some work on this function also. And here also, I'll give him the references here. And just due to short of time, I'm just indicating my definition, but it is not time to elaborately discuss, just giving two metric space. This definition 1.1, definition 1.2, distribution. This is the important role in my paper. Distribution function. Everyone probably here distribution function I have taken, that is left continuous, infimum 0, 1, and non-negative function are. Probabilistic metric spaces, it is a connection between metric and probabilistic metric spaces. That is, if I can take in metric spaces, we know that dxy. Dxy is the distance between xy in usual metric. But in case of probabilistic metric spaces, instead of metric, we can use the probabilistic distribution function. That is fxyt. Fxyt means the probability of distance between dxy less than t. That is the connection in a given example, Heaviside function. If we can take Heaviside function, there is a connection between probabilistic metric space and metric spaces. Fxyt equal to ht minus dxy. That is the connection. And that is the probabilistic metric space. It is the important definition. In my paper also I have used. And t-norm. T-norm actual triangular inequality. Triangular inequality, nf type t-norm. And nf time t-norms, there are so many t-norm. We know that minimum t-norm, product t-norm, Lucasite t-norm, drastic t-norm, so many t-norm there. And here I have used the product t-norm. Product t means del dt del ab equal to a dot b. But in case of, in my patent paper, I have used third order product d abc equal to a dot b dot c. And this is the vital rule of Menger space. They accept delta be a Menger triplet, except delta x is non-empty set. That is the distribution function x cross x to d, and delta is a triangular t-norm. And property 1, 2, 3, 4, these four properties if holds, then we get the Menger spaces. And then their probabilistic another, by triangular we can get the probabilistic two metric spaces. Here, two Menger spaces. This is the important definition, and we all every know the Cauchy sequence and convergence. But in case of, here we use the Cauchy means if xn a epsilon greater than equal to 1 minus lambda, that is Cauchy convergence property, and Cauchy sequence if xn a epsilon greater than equal to lambda. These two it is important for my main results. And here phi function. This is the important role. This function is important role in my papers. Phi function is the control function. And my guides, I have just said that my guide established this result, phi function phi r to r plus, that is phi t equal to 0, if and t equal to 0, phi t is strictly monotone increasing, and left continuous, phi is continuous. And we can give an example, phi t equal to t, root t, so on, or we satisfy all conditions. That is the control function. And there are so many papers, recent time, many authors are using this result, this control function, different type of result given. And now I am just giving main results. This is my main result. Main result means except delta be a complete two Menger space. Complete means every Cauchy sequence converts this space. That is complete two Menger space. Delta is a third order product genome. Just I have read, told. Tx to x be a mapping and satisfying this contraction 1 by ftx ty a phi t minus 1 less than equal to mean of 1 by fxy a phi t by c minus 1, 1 by x txa, phi t by c minus 1, 1 by f y ty, f phi t by c minus 1. This is the main result. And due to short time, I am not giving completely proof, just giving this result. It is established result. I have established this result where t greater than 0, c lies between 0 and phi is a phi function, and then t is unique fixed point. And this type result actual a renowned mathematician Siri just died before 2 years. Most well 2 years he died. And name I am dedicated my paper in this Siri, Professor Siri. This type of contraction actual name just like Siri type contraction, but it is rational type contraction. I have established this result. And here corollary, let except delta be a complete two-member space, tx to be a mapping, and satisfy condition 1 by f tx ty a, t minus 1 less than equal to 1 by x tx a, phi t by c minus f x tx, sorry, it is a typical mistake. First term will be 1 by x y a t by c, next term x tx a t by c y t y. It is typo mistake, sorry for this. And t greater than 0, 0 less than c.
Sir?
A fixed point. Yes, yes.
Sir, kindly conclude your paper, sir.
Okay. Next, here I have given a example for supporting this result. And here, this is a conclusion that this type of result, why it is important? It is important in case of numerical analysis, in case of differential equation, integral equation, and recent time, Professor D. Gopal and so on, author trying to establish this some result on fusion, nuclear fusion also. So it has an importance in case of different type application also. And just here some important references. Due to short time now, just I am finishing my presentation. Thank you, everybody.
Thank you for your nice presentation, sir.
Yes, ma'am. Yes, ma'am.
Only one question from my side, sir.
Yes, ma'am. Yes.
Can you explain your idea to n Merger space, sir? We have discussed about 2 Merger space.
Oh, yes. 2 Merger space. Yes, ma'am. I'm giving like actual Menger space in 1942 K Menger established the Menger space, but 2 Menger space actual 2 metric converts probabilistic version as Menger space, and 2 metric each conversion is 2 Menger space. 2 metric is probabilistic version. The probabilistic version of 2 metric is 2 Menger space. And when is established first time this concept introduced 2 Menger, and I have established my result in these spaces.
Thank you, sir. Thank you very much.
Thank you.
Vinolin? Vinolin, call the...
Ma'am, the next presenter is Dr. Babadosh.
Who is the next presenter?
Sir, Dr. Babadosh. Dr. Babadosh. Sir, are you in the meet, sir? Sir, present now, sir.
I am present here, madam. Hello.
Yes, sir. Dr. Babadosh.
I am present here, madam. Yes, madam, I am present here.
Oh, okay, sir. Okay, sir. Present now, sir.
Okay, madam,
Your
I am
voice is
trying.
clear, sir. Screen is also visible. Okay. Sir, not able to hear your voice, sir.
Yes, madam, I am uploading my PPT.
Okay, sir.
It is visible now. My PPT is visible.
Yes, sir, it is visible.
Okay, we'll do okay. Hello. Good afternoon, everybody. My topic is strategic analysis using multi-server queuing model for effective business. Abstract of my topic is queuing theory model play an important role in effective business analysis and to design new policy for grow the business in present competitive environment to attract the customers is a big challenge for executives. Introducing some new policies and other offers on product and services play a vital role to attract customers due to good attractive offers of the company. New customer attract toward the company to take product and services. Such type of customers is known as motivated customer due to motivation policy of the company. Intake of customer increases in the system and result is heavy rush in betting areas and also in betting time. Due to long waiting, customer can get impatience and may leave the system without getting service. Such type of behavior of customer is known as reneging. Reneging of customers is a loss of business, and so it is very important for any organization to design strategies to retain the reneging customers. This paper concerned to analysis of a two-server Markov-Chain queuing model with reneging of customers. We obtain expression for steady-state probabilities of the queuing model using iterative procedure. Further, we obtain some important performance measure of the queuing system. Outline of the paper are as follows. Queuing theory is the mathematical study of the congestion and delay of waiting in line. This is the queuing system. Customer arrivals, queue, enter service, servers in service facility. After taking service, a customer can exit from the system. Basic terms of the queuing system. Customer behavior in the system. Customer can bark before joining the queue. Customer can renege after joining the queue due to long waiting time. Customer can jockey from one waiting line to another waiting line due to his observation. We can take fast service in other queue. Here we consider MM2K queuing model. Customer arrive in the system according to a Poisson process with mean arrival rate lambda. The service time of customers are responsibly distributed with parameter mu, where mu is the mean service rate. There are two servers serving customer in order of arrivals. Customer who see at arrival K other customer in the system are lost. Here, two types of customer arrive in the queuing system. First type of customers are normal customer who arrives in the system in a Poisson fashion with arrival rate lambda 1. And second type of customer are motivated customer who join the system to take the service due to some motivational scheme launched by the organization. These customers also arrive in a Poisson fashion with arrival rate lambda 2. Service facility of the queuing model has two servers to serve the customers. The service time are distributed independently, identically, and responsibly with parameter mu. The customer are served in FCS fashion, first come first service fashion. The capacity of the system is finite. Here the capacity of the system is K. When customer join the queue, he wait for service for a certain time. The customer become impatient if he is not served in that time and may leave the queue with probability R1 and may remain in the queue for his service with probability R2. Nu is a reneging rate of the customer. This is the transition rate diagram for a queuing system, MM2K queuing system. The differentiation for described system are these. For steady state, these equations become in the form 6 to 10. After solving these equations, we get the general solution of the system Pk equal to this, where Pk be the probability that there is k customer in the system at time t. Using normal condition of the queuing model, we get P naught, this performance measure of the queuing model, expected system size LS equal to this, expected queue length, average rate of reneging, average rate of retention, expected waiting time in the system, expected number of customers in the system, probability distribution for busy period. This paper studies a queuing model with two types of arrivals, normal and motivated, reneging and retention of reneged customer. Here we obtain the steady state solution by using iterative procedure and different performance measure of the queuing model. In this paper, the model analysis is limited to finite capacity and for only two server. The finite capacity case of the model with multi-server can also be studied. More than two servers can also be studied. Model can also be solved in transient state to get time-dependent result, and cost-profit analysis of the model can also be carried out to study its economic analysis. These are references which we have consulted for this paper. Thank you.
Ma'am?
Hello.
Ma'am, Isha, ma'am?
Yes, Rita. Sir, thank you for your nice presentation,
Okay,
sir.
okay, thank you, madam. Thank you, madam, for giving a chance for presenting my paper, because due to some problem I can't upload at first time my PPT. Thank you, madam. Very, very thanks, all
Thank
of
you,
you.
sir.
Okay.
Thank you very much, sir. Vinolin?
Yes, ma'am. Ma'am, the last paper presenter is Mr. K. Keshav Kumar, ma'am.
So, he is the last candidate.
Yes, ma'am, yes.
Okay, okay.
Good evening, madam. Is it audible, madam?
Sir. Good evening, sir.
Yes, yes.
You present your paper, sir.
Yes, madam.
Present now, sir.
Yes, madam. I'm starting now.
Present now, sir.
Yes, madam. Wait 1 minute. Just. Is it visible, madam? Is it visible now? Is it visible now?
Yes, sir. It is visible, sir. Visible, sir.
Thank you, madam. So, good evening, all. I'm going to give a paper presentation on mathematical modeling and its profound applications.
Yes, sir.
The whole,
Yes, sir. Visible, sir.
Yes, madam. The whole world is in crisis due to COVID-19 pandemic, the present global health threat from the novel coronavirus. One may have the following questions. The first one, how the world's people and their governments arrive at estimates of the number of people who might get affected due to COVID-19? How do experts visualize the progress of the infection and its capacity to cross borders? How can experts predict how long an pandemic will last? So all these questions, along with the other crises, fall in the economy due to lockdown. All these answers lie in the application of mathematical modeling. So the objective of this is to study what is mathematical modeling, to study how models are arrived, to study modeling process and the applications of mathematical modeling and its limitations. So basically, mathematical modeling is the formulation in mathematical terms of the assumptions believed to underlie a particular real-world problem. Mathematical modeling is the process of deriving such formulation. So how these models are derived? There are 5 steps basically. Start with the problem of interest, make reasonable simplifying assumptions, translate this problem, physical problem, into a mathematical problem, and give the solution in terms of the physical problem. So this is what the modeling process goes on. A real world problem will be converted into mathematical world, where we use the mathematical equations, we model the physical situation and give the solutions back to the real world problem. So here it's a simple math model where it is a biological problem where the ages of father and son is given and is asked what is the age of father and son after 3 years. So this is converted into mathematical equations, and x is represented as the present age. Then it is converted into mathematics, and using the algebraic formulations we can get into the problem can be solved. So this mathematical modeling is categorized into various categories: mathematical modeling according to the subject matter, mathematical modeling according to the mathematical techniques, mathematical according to the purpose. Okay, if we are interested in the prediction, we call it as mathematical model for prediction. If we are interested in the control of the disease, we call it as mathematical modeling for the control. And optimization, we call it as mathematical model for optimization. Similarly, on the left hand side, it is based on variables, it is based on chance factors, that is whether the model is static or whether the model is dynamic. Mortality, it is the death rate, immigration coming into the population and immigration going away from the population. So in basic terms, population growth can be represented as a equation: natality plus immigration minus mortality plus emigration. So under this, we take the basic exponential growth model, which is basically the present COVID-19 virus spread. It is if n is the number of population present at any time, then it is represented as the rate of change of the population at that time is directly proportional to the number of population present at that time, where dn by dt is equals to r into n, where r is the proportionality constant. If r is positive, we call it as exponential growth, and if r is negative, we call it as exponential decay. So this is using the variable separable method, we can find out the equation, solve the equation, and this is what the COVID-19 cases around the world. So if you see the green color, it is the number of confirmed cases. It was growing exponentially till the April. Okay, this date is given as 13/4/2020, but after April, May, it was converting into logistic model. So basic examples of exponential growth are the aliens. When a new species is introduced accidentally or deliberately into a new environment, since it has no natural predators or no diseases to keep it under control, it exponentially grows. Similarly, the pest species show exponential growth. But in nature, basically, it does not happen. What Darwin has observed that, okay, the population of the growth cannot grow exponentially because of its environmental factors and the resources available. So it converts into a more realistic model called as logistic growth model, where it is controlled by a carrying capacity. So it is the logistic growth model is given by dn by greater than k, dn by dt will be negative. So it decays after reaching that particular carrying capacity, which is represented in this particular logistic curve. It has three phases. First phase, we call it J to L, is called as exponential growth. After reaching M, it will be from L to M, it will be constant. But after reaching M, that is the carrying capacity, it tries to go as the decay model. It does not grow exponentially. So another example is climate modeling. So this climate modeling is basically based on simple energy balance, where you have energy input minus energy output. So it's like the weight of a human body. The weight increases if you do not do the exercise. Okay, if you just eat, the input will be the eating habit, data very well, but leading to erroneous conclusions. So there should be a trade-off between the model assumptions as well as the fitting of the data. So these are the references I have used for my study. Thank you, madam. Thank you very much for giving this opportunity.
Thank you, sir. Thank you for your nice presentation, sir.
Thank you.
Very much. Okay. Special thanks
for
to you, Anita.
sparing your valuable time with us, ma'am. Thank you so much, ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.